Theorems of the derivative and the tangent line. In this presentation, we will cover what a derivative is, its geometric meaning, secant and tangent lines, how to compute the tangent line, important theorems related to derivatives, examples and applications. Introduction. The derivative is one of the most important concepts in differential calculus. It allows us to measure how a function changes and to understand the behavior of this graph. The most fundamental geometric interpretation of a derivative is the derivative at a point gives the slope of the tangent line to the curve at that point.
What is derivative? The derivative of a function at a point measures its instantaneous rate of change. That is how fast that function is increasing or decreasing at that point. Formal definition f prime of f equals the limited as h approaches 0 of f minus f of a over h. Geometry interpretation. Example 1, if f a prime of x is greater than 0, the function is increasing. Example 2, if f prime of x is less than 0, the function is decreasing. Example 3, if f prime of x is less than 0, the function is increasing. The line is horizontal. The second line, before understanding that tangent line, it's useful to consider the secant line. A secant line connects to three points on the graph of function. The slope of the secant line m6 equal f points means f of a over b minus a. The secant line gives the average rate of change between the 2 points as the 2 points get closer. The tangent line. The tangent line is the line that touches to a curve. The tangent line is the line that takes the curve it's against one point, and the representation the direction and represents in which a function is heading at a point. A slope of tangent m tangent is equals from a equation of the tangent line. So the tangent line is a minimum f of equals f prime of a time minus a. The tangent line is the line that takes the curve and its point and represents the direction in which the function is headed and the point. So look of the tangent m that it equals of prime of a. equation of a tangent line y minus f all equals f prime of if x minus o. Before starting tangent line is usually considered the secant line. Example, a means of x equal f prime of a times x minus a is the best linear approximation of a function x equal a.
Can please have some por let we find sham be we calculate the be effective where we value is the derivation of the points. We find the points of cocktail. We write the Tenheim lab. Men by love them orem is one of the most important theorem that concept the seven you second and on them derive like they made if a from chain is coined they knew on lay to be derivatable on el to be on el to on el to be they vary seem at length 1.7 a to be some days you may dream interpretation that you should if the second like be a of and the f the shall chief shop of attention like its side with its terabytes.
Example: tangent line to the point. Step 1. Given the function fx equal x cubic, point of tangency equal to 2, therefore f2 equal 2 cubic equal 8. Okay. The point of tangency is P8. Step 3. Derivative of the function fx equal 3x squared, evaluating at x equal to f2 equal 3x squared equal 12. Yeah. Step 4. Equation of the tangent line using the formula e minus e0 equal mx minus x0. Substituting e minus 8 equal 12x minus 2, which gives us y equal 12 minus 16, y equal minus 4. Okay. Example of a differential theorem, quantum Rule theorem. If f(x) and gx are differential functions, then f(x) divided by gx equals f(x) times gx, minus f(x) times gx all divided by gx squared. Okay, the example, x equals x squared plus 1 divided by x plus 2. Okay. Step 1. Identify the functions. Fx equals x squared plus 1. So if x equals 2x, okay? Gx equals x plus 2, so gx equals 1. Okay. Step 2, apply the quaternion rule. Okay, x prime of x is equal to 2x times x plus 2 minus x squared plus 1 times 1 divided by x plus 2 squared. Okay. Simplifying, we had, okay, x prime of x is equal to 2x squared plus 4x minus x squared minus 1 divided by x plus 2 squared. Okay, minus squared which is equal to x squared plus 4x minus 1 divided by x plus 2 squared. Okay. Application of the derivatives on tangent lines. In physics, instantaneous velocity, acceleration, economics, marginal cost, marginal renewal, engineering, optimization, structural modeling, mathematics, understanding graph behavior, linear approximation of functions. Conclusion: the derivative gives the instantaneous rate of change of a function. The tangent line provides the best linear approximation at a point. The slope of the tangent line is equal to the derivative. Fundamental theorems such as Rolle's theorems and mean value theorem ensure the existence and properties of derivatives. And that's all. Thanks.